Hi everyone, this will be your video for even and odd functions. There'll also be guided notes that'll be attached to your Google Classroom post. So first we're going to talk about even functions. So if a function is even, by definition or algebraically, that means if you plug in a negative x and you simplify, you're going to end up with your original function. So you're going to end up with f of x. Now, if we're looking at a graph of an even function, it does have symmetry, and it's symmetric about the y-axis. So that means that like your y-axis is your axis of symmetry, if you want to think of it like that, or it's almost like the mirror for both sides of your graph. So you can see down here that it says if AB is on a graph, we would also get the same outcome. If we plug in negative A, you're also going to get B. So if you have AB and it's even, you can also assume that you're going to have negative AB. So an example of an even function, this is a fairly simple one. It's just a nice little quadratic. It's a parabola. It's the parent function here. And you can see that the equation is y equals x squared. Its graph down here, you can see that there would be this like vertical line of symmetry right down the y-axis. So when it is y-axis, you know that that's going to be an even function. We know that if we have the point 2,4, which you can see is right here, we're also going to have the point negative 2,4. I couldn't fit it in there. So negative 2,4. So you have this same point. It's mirrored across the y-axis. Now, algebraically, you can also figure this out without graphing a function, and that's by plugging in negative x. So when you plug in negative x and you simplify, you will get the original function if it is even. So this turned out to be our original function, which means that it is an even function. All right, so let's switch gears and start talking about odd functions. So we have this same idea of if you're plugging in a negative x, your outcome is going to determine what type of function. So now you can see that we're coming and our output is the opposite of our original function. Everything's going to be negative. All of our signs are going to be opposite. And if that's the case, then it is an odd function. So there was a little typo here on your guided notes that you have on your assignment page. So make sure you just change it. It did say even. This is supposed to say odd because we're talking about odd functions. So the graph of the odd function is going to be symmetric about the origin. So what that tells us about our points is that if we have AB as a point on our graph, negative A, negative B is also going to be a point on our graph. So you can see down here we have a sample of a very simple odd function. Let me connect the dots here. Okay, so we have the function 3x, y equals 3x. If we know that the point 2,6 is on the graph, and I know that it's an odd function, that's telling me that negative 2, negative 6 is also on the graph. Now we can also test this out by our theory. So if we plug in a negative x, for our x here, we end up with negative 3x, which is the negative f of x. So that's telling us that this is going to be an odd function. Okay? So if there were more terms, they would all need to be opposite as well, opposite sign. Okay, so here we are for how to simplify exponents. This is probably the part of this lesson that most people will make mistakes on, so we need to make sure that we're really clear on how this works. So if you have an even exponent and you're plugging in your negative x, if it's an even exponent, it could be 2, it could be 202. As long as it's even, your term will stay the same sign. Okay, so that means if we want to see an example of that, if we had the function y equals 2x to the 4th minus x squared, and we're trying to find f of negative x, we're going to plug in our negative x here. Now the biggest thing that you need to remember is that this negative x is on the inside of the exponents. So you want to make sure you're using parentheses and grouping appropriately. So when it's an even exponent, that means that that term will stay the same sign, and that's because now your variable will become positive. It's not going to change anything. So we're going to end up with 2x to the 4th. And again, we have this negative x squared. It's an even exponent, so that means that this minus sign for the term is going to stay, and then this becomes x squared. So the signs stay the same. Now let's talk about odd exponents. So if you do have an odd exponent and you're plugging in a negative x, you're going to be getting an opposite sign for that term. So for instance, if you have y equals, we'll do 3x to the fifth minus x. Okay, it's going to become the opposite sign. When I'm plugging in negative x for all of my x's, you have to remember how the exponents work. Okay, you do your exponents first, and if it's an odd exponent, it's going to stay negative, which is going to make your whole term an opposite sign. So this now becomes negative 3x to the fifth, and then this becomes plus x. It's going to change every term to its opposite sign when you're plugging in a negative x to an odd exponent. All right, so here we are with an example. Now this one is worded a little bit differently than you'll see most often, which would just say, determine if even or odd. Now you can also remember that there is an option for it to be neither. And that's just basically if it's not exactly the same and it's not exactly opposite, you can just say it's neither. Okay, so no matter what they're asking for, you're always going to just insert that negative x for all of your x's, and then from there evaluate, is it the same, is it exactly opposite, or is it neither? So we want to find what f of negative x is. So we're going to be plugging in a negative x for all of our x's here. Make sure that you're using the appropriate notations. And so we can go through and simplify. So I know if I have a negative to an even, it's going to stay the same sign. So this was a positive x to the fourth, so it'll stay a positive x to the fourth. If I have a negative to an even again, it's going to stay the same sign. So this was negative 3x squared, so it's going to be negative 3x squared. And then I have my plus 5. So you can see this is exactly what we started with. So since this is our f of x, it is even. Okay, so exactly what we started with. If it's your original function, it's even. So here you can see another example done out. Again, the directions say something a little bit different. This one says, show that it has origin symmetry. For us, we know origin symmetry is odd. O for origin, O for odd. But another way you could see these directions would just be find the symmetry, or, determine if it's even or odd. So same process here. You're plugging in a negative x for all of your x's. A negative x to an odd exponent will change the sign of the term, so now that term is negative. Negative exponent, this is technically still an odd exponent, it's a 1. It's going to change the sign of the term. So when you're looking at this, it's exactly the opposite of what we started with. We have all of our terms are opposite signs, meaning that it's negative f of x, which then tells us that this is an odd function. All right, so this is our last one, and we'll do this one together. And again, the directions say determine the symmetry or determine if even or odd. You know that you're going to be doing the same thing no matter what. We're going to be plugging in a negative x to all of our x's. So we're going to have negative x squared plus 5 times negative x, and then minus 6. So again, a major error is seeing you have a negative times a negative and making this positive, when in reality you need to do your exponent first. So do not fall victim to this easy little mistake of negative times a negative. Remember your order of operations: exponents, then multiplication. So we do have a negative x to the second power, which is even, meaning that that term is going to stay the same sign. It's going to stay negative x squared. Then we have negative x to the first, so that's going to make this a negative 5x, and then minus 6. So as we're looking through, it looks like our first term stayed the same. It looks like our second term switched signs, and our third one also stayed the same. So the fact that they all didn't change, or that they all didn't stay, and now it's just kind of all mixed up, this would be a neither. Okay, and that's because they're not exactly how we started, and they're not exactly the opposites. All right, so here's our summary of our topics from this week. Again, if you didn't write anything down, pause the screen, and this is a great page to write down for yourself. And it's just a few notes. So it's telling us that if we have an even function, it's going to have y-axis symmetry. We know that. That also tells us that if we plug in x, we'll get y. And also if we plug in negative x, we'll get y. So a different way of thinking of this is that if you're plugging in negative x, you're going to get your original function. Okay? Then we can go down to our odd functions down here, and that we know that odd functions have origin symmetry. And also, if you're plugging in x, you get y, and then you'll have the opposites. Negative x will give you negative y. And the way you can think of that is that if you're finding f of negative x, it's going to become the exact opposite, so negative f of x. All of your terms will be opposite.